Good afternoon, sir.
Good afternoon, students. Can you hear me?
Yes, sir.
Okay, so far only six students has joined. Okay, so let the other students come. Then I'll start. Okay, good afternoon, students.
Good afternoon, sir.
Okay, so last class we have discussed about the von Neumann architecture. So today I will discuss about the negative number representation in computer. Okay, and with the from the negative number representation, we will move to the floating point number representation. So both are very important. first tell me, can you able to see the window?
Yes.
So how computer represent negative number? What's your idea on this? Because you have read the similar thing in C programming. Because when we deal with the hardware, when we write some negative number, how computer represent? Tell me. তুমি বলতে পারবে? Tell me yes or no.
স্যার নেগেটিভ নাম্বার ইনপুট করার জন্য আগে একটা ভেরিয়েবলের মধ্যে সেটা ইনপুট নিতে হয়।
No, I know that. That if you write a equals to minus 2, the things will be stored, the negative number will store into the a, and finally it will be stored into the memory. I know that. I am asking to you how this negative number will store in the binary form. That was my question.
নো স্যার।
Because you are reading the computer architecture, this is a very close related to hardware. But how hardware it will be stored? In hardware we only know that 0 and 1s. Apart from 0 and 1s, hardware will not be able to store anything else. So the computer uses 2's complement form. Okay, I hope you know that the 2's complement form. Another one is 1's complement form, and last one is sign magnitude form. There will be three forms to represent a number, negative number in the computer. So what are these three? So first starting with the sign magnitude form, let's a number, let's say 4. 4 number is in decimal, okay? What will be the equivalent binary of 4? What will be the equivalent binary of 4?
Sir, 0100.
Okay, 0100. Now this is, you have told me the representation in 4 bit. If same thing I have represented into 8 bit, so I have to add extra 40 at the end. So total 4 has been represented in 8 bit. Now the leftmost bit, this is the leftmost bit and this is the rightmost bit. This bit is called as LSB and this bit is called as MSB. What is LSB? Least significant bit so just a minute. I'm back. Hello. So what I am talking about, one is the least significant bit, another one is the MSB is the most significant bit. Least significant bit and most significant bit. Okay. So now the MSB is considered as a sign bit. The MSB bit is considered as a sign bit. So which bit will be considered as a sign? This bit. Only this bit. And the remaining bit will be the magnitude. The remaining bit will be the magnitude. So magnitude specifies the value and sign specifies the sign of that number. So we have two options in the MSB, either 0 or either 1. So 0 stands for positive number, 1 stands for negative number. Okay, so I am writing plus 4. So when I have converted this plus 4, so that you can see that MSB is 0, so it is specifies 4, and what is how we can compute 4? So that is by this magnitude. So if you can convert into decimal, you can get 4 in decimal. Understood or not?
Yes, sir.
Now, what is 2's complement and 1's complement? So if we take the same one, 4, so 4 in 8-bit representation, 4 in 8-bit representation, it will be 3, 4, 5, 1, 0, 0. So this is the number when I have converted to 1's complement, which means each bit will be toggled or each bit will be converted to vice versa. So 0 becomes 1, 0 becomes 1, 1 becomes 0, and all the remaining ones. So that's why I'm writing 5. Now you can see also. Now what is the sign bit? This is also the sign bit, plus bit, MSB. Now MSB becomes 1, right? Now when MSB becomes 1, I can say that this is a negative 4. So
Yes, sir.
MSB is 1. So it is equivalent to minus 4. ठीक है sir? Again 2's complement. Again I am calculating the 2's complement. So what is 2's complement with the same example? So this is 0, 0, 0, 0, 0, 1, 0, 0. When I am making the 2's complement, which is nothing but the 1's complement plus 1. So what is the 1's complement of this number? We have already computed in our previous example. It is 1, 1, 1, 1, 1, 0, 1, 1. Now if we want to make as 2's complement, I have to add an extra 1 with the output of the 1's complement. So this is the output of the 1's complement. So when we sum of them, what we get? We get 0, 1, 1, 0 carry 1, 0, 1, all the negative will be, all the remaining bits will be 1. Now you can tell me what is the MSB or in 2's complement? The same thing, this is 1. Now this is the MSB. So MSB is 1. So it is a negative number. It is a negative number equivalent to minus. Now what should we pick? Because we can see that both 1's complement and 2's complement will give you the negative number representation. Now what should we pick? If we are making a compiler or if we are making a underlying hardware, what complement form or what mathematics we should use to make the digital complement? So all the modern computer uses 2's complement form. Now, what is the reason behind that? Do you know the reason? Do you know the reason? Speak up. I have already told in my introductory class that you need to speak up. This is not my class. This is also your class. You can add your opinion.
Sir, questionটা আবার repeat করুন।
The question was, I have already shown that two ways we can represent the negative number. One is ones complement, two's complement. When we have make and ones complement of a number, the MSB changes from positive to negative and vice versa. So now the question is, out of these two, which should be the pick to make our digital computer? Ones or twos? The correct answer is twos. But what is the reason behind that? That was my question. কজন ক্লাসে আছো? মহিতোষ গিরি, not responding. Pallavika Pal,
Yes, sir.
why we should use two's complement? This is not the computer architectural thing that I am asking to you people. This thing comes with the concept from C programming. So that's why I am asking you. If the things is new, definitely I will not ask you. Next, Pritam.
Yes, sir.
You heard the question? Rahul Kumar. Rahul Kumar, not responding. Shani Kumar Shah.
Yes, sir.
Can you give the answer? Tanushree Maji. Not responding. Okay. So, if we can say, we will do some test case with +0 and -0. Now I am taken as 0 in decimal. I have converted it to binary into 8 bit. 0, 1, 2, 4, 5, 6, 7, 8. So this is the equivalent binary digits in 8 bit for 0. Now if I want to make ones complement of this number, what I get? I get
1.
8 ones, right? Now the question is, if I convert into 2's complement, what we will get? Plus 1.
0,
1, 1, 0, 10, 1. Now, this is the last carry 1, right?
Yes, sir.
Now I have already told that I have 8 bit availability. So I can use this only 8 bit, not beyond that. Now the 1 has been generated in which bit? That is in the 9th bit. So that's why in case of, if you remember the 2's complement addition, always with the carry will be different. Okay, so what we actually get, we get this is as an equivalent -0, which is equivalent to -0 in decimal, and in 1's complement, this is the equivalent -0 in 1's complement, and it is in 2's complement. Now tell me, in your decimal mathematics, +0 is equals to -0 or not? In decimal.
Yes, sir.
In decimal, +0 is -0 and same. Now the question
Yes,
is,
sir.
if you making a system by using 1's complement method, what will be the problem? +0 and -0 are two different entities. Because +0 bit structure is all 8 zeros and -0 bit structure is all 8 ones. So that is the contradictory. But if you can see the bit structure of 2's complement -0, you can see that this is same as the +0.
স্যার ওটা +0 হতো না?
কোনটা বলো তো?
স্যার
কোন
2s
জায়গাটা বলো?
কমপ্লিমেন্টটা ইকুইভ্যালেন্ট দিয়েছে। 2s কমপ্লিমেন্টে
না
যে
না,
সবকটা 0 হয়েছে।
হ্যাঁ এটা তো +0 কেন হবে? 2's complement করে আমরা কি পাই? দেখুন আগে যেটা পড়ালাম আমি, এই যে 2's complement, when we do the 2's complement, what we do? We always get the MSB at 1. So it is also a representation of negative number. So you have two options. One is you can form a 1's complement to get to say this is a negative number, or you can go for 2's complement. Now the question was, the argument was that which should we pick, either 2's or 1's. So in 1's complement I am showing to you that +0 and -0 structure are different, but in decimal we always write +0 equals to -0. So in binary the pattern should be same. But when we have doing the 2's complement, what we get? We get the same pattern as the +0 is equivalent to -0. Now understood?
Yes, sir.
Okay, so that is the reason. Because if we try to make a system by using 1's complement methodology, you can represent negative number, but the biggest mistake will be you cannot try to make same as +0 and -0. They always be different. But in your mathematics, if you making a system in 2's complement, and if I write that 5 minus 0 is equals to 5 minus +0, so this will not be preserved. So in case of 2's complement method, this thing will never be preserved. That will be not equals to, which is a wrong in our mathematics. Because -0 is all 8 ones, +0 is all 8 zeros. So if you want to different from 5 from a constant number, both the cases I have used a constant number, so you will get a difference. So that's why all the modern system will use the 2's complement as a negative number representation. মনে থাকবে তো সবার?
Yes.
Yes, sir.
Okay, and very interesting thing in C programming, if you write int a equals to 10, if you write then int b equals to negation a, negation a means it is, negation is 1's complement, 1's complement. Okay, if I write print f b is percentage d comma b. Now tell me what is the output. বলো আউটপুট কি হবে? আউটপুট বি ইজ কত?
স্যার একবার অ্যান্সারটা বলবো?
একদম অ্যান্সারটা বলো। তোমরা কম্পাইলারেও চেক করে নিতে পারো, এনি কম্পাইলারে ফেলে চেক করতে পারো। দেন উই উইল ডিসকাস দ্য এক্সপ্লানেশন অন দিস।
সেটা কি -10 হবে স্যার?
আমি আনসার লিখে দিয়েছি, দেখে নাও কম্পাইলারে। It will be -11. If you write 5, a equals to 5, it will be -6. If you write a equals to 100, it will be -101. Always. Now, what is the condition? What is the logic behind that? See here. So, solve in line by line. Okay. So, first I have introduced a equals to 10. Okay. So, 10 will be stored in which form? Binary form 1010, and I have taken a 8-bit representation, right?
স্যার
Now, when I
এমএসবিটা
am
তো 1 হয়ে যাচ্ছে,
তুমি
তাই তো
লজিকটা কি
এখানে
বলতে পারবে? -11 কেন হলো বল?
কারণ স্যার এমএসবি তো 1 হয়ে যাচ্ছে যখন ওটা কমপ্লিমেন্ট হচ্ছে, তো তার জন্যই মাইনাসটা আসছে।
So minus, so okay, you just tell me. So when I have taken negation of a, that means one's complement, right? So if it is one's complement, then all will be toggled. So 0, 1, 0, 1, right? So out of this, which one is sign bit? This is sign bit, right? So it is a negative number. And what is the magnitude? This is the magnitude. This is the magnitude, right? So if this is the magnitude, what will be the result? This is will be minus, according to you, that will be minus for this sign, minus for this sign, and the magnitude will be 0, 1, 2, 3, 4, 5, 6. 128 plus 64 plus 32 plus 5. Okay. So what will be the actual answer need to be shown? So 7, 11, 19. So this should be the answer, but why it is showing -11? If you are saying that sign bit is becomes changes to 1, that is true, definitely. I am not telling that is wrong. But after getting the decimal output, it should be -229. So why it is saying -11? That was my query. Understood what you are trying to say? Tell me. বলো স্পিকার, তুমি তো একটা কথা বলেছো, আমি তার একটা এক্সপ্লেনেশন দিয়েছি। whether you are convinced with that explanation or not, then speak up.
কারণ স্যার এখানে 2s কমপ্লিমেন্টটাও হয়ে যাচ্ছে তার জন্য।
How? সেটা বলো, explain me clearly. How? If you are appearing in the interview, you have to explain to the interviewer. As a teacher, I are asking you 10 times, 20 times, speak up. They will not ask you. You have to answer prominently. That is the reason. Now tell me the reason. Okay. So after doing this negation, what will happen? The sign bit becomes 1. So what I told, When sign becomes 1, what computer thinks? This is going to a, this is going to be a negative number. This is going to be a negative number. So when computer thinks that this is going to be a negative number, then computer always represent it in 2's complement form. So the machine will convert it to the 2's complement form due to the 1 in sign bit position. Due to the 1 in sign bit position. So what it do? It will convert into a 2's complement. So it will convert the 2's complement of negation number. So what is the 2's complement? First compute the 1's complement. 0 0 0 0 1 0 1 0 and then an extra 1 to the result. So it becomes 1 1 0 1 0 0 0 0. Now this is the sign bit is become positive. So what is the magnitude? This is the magnitude. This is the magnitude. So if you convert the magnitude 0 1 1 1, so what we get? We get 11. Now the question is, computer represent it in 2's complement form. Computer already represent it in 2's form, 2's complement form. So, and you are using in which as a format specifier percentage. Percentage D for decimal, right? Percentage D for decimal. So when this format specifier comes to print the output, so though the computer already represent is 2's complement form, so it will give the output. It will give the output in negative side. So together what we get? We get magnitude at 11 and we get a combined sign negative. So final output or the output will be displayed output will be minus 11. Now tell me if you have any query or not. See the things carefully and let me know. Follow. বলো সায়ন দে। অনিরুদ্ধ দে, দেব হালদার,
ইয়েস স্যার।
বলো।
মানে স্যার কি বলবো, মানে ওইটা
So how the things in being displaying বোঝা গেছে? If
Yes,
we
sir.
give
Yes, sir.
if we give 6, if we do the negation, it will be -7, not -6. Because of this, all these intermediate steps.
ইয়েস স্যার, ইয়েস স্যার। এই সাইন বিটটাই স্যার ইফেক্ট করছে। যখন স্যার সাইন বিটটা 1 হচ্ছে, তখন ওটা 2s কমপ্লিমেন্টে কনভার্ট হয়ে যাচ্ছে, কারণ ওই সাইন বিট যখন 1 হচ্ছে, কারণ এটা নেগেটিভ নাম্বার
Because
ইন্ডিকেট করছে।
yes, because actually you are forcefully do the ones complement, but once after doing this ones complement, the sign bit become changed. Now when the sign bit becomes changed, computer will think this is a negative number. So what is the algorithm to represent the negative number in the computer? That is the 2's complement. So computer is actually doing the 2's complement of the 1's complement that you have just did. So finally, in 2's complement extra 1 will be added. So that's why the result will be added with extra 1. Okay, so that same will be applicable any of the program, and that is the reason for this architectural view.
স্যার তাহলে যদি ওই সাইন বিটে যদি 0 চলে আসতো, তাহলে ওখানেই পজিটিভ নাম্বার হিসেবে শো করতো, দেন ওখানেই তো স্টপ হয়ে যেত প্রোগ্রাম।
একদমই তাই, because when we write that int b equals to 20, if you printed %d comma b, then what will be the answer? 20. Because when we represent 20, if you represent it into the bit representation, I can show you. So let's say this is 20. If this is 20, so what we get? This is 16, 8, 4. So this is 1, and this is the remaining 3 bit in 8 bit representation. So here it is your sign bit is 0. So sign bit 0 means computer will think that this is positive number. So to represent the positive number with nominal bit arrangement, no issue. So computer will not doing what it will done in case of negation. Understood? It will give you the magnitude with the sign. So this is your sign, and the remaining is the magnitude. So finally, we will get the, in case of we will get the output as 20 only. I hope it is clear now.
ইয়েস স্যার, ইয়েস স্যার।
Okay, so this was the negative number representation. I hope you will remember those all the stuffs, and from the next class onwards we will discuss the IEEE 754, that is the floating point number representation, that was done in the negative number representation, and in the from the next onwards we will discuss the IEEE 754. And here also you will see that 1 bit is also already reserved for the MSB, is already reserved for the sign bit. Then how we can represent this decimal point? Okay, so it's done for today.
Thank you.
Okay, you may leave now.